Hey everyone. Sorry, I don't have my normal microphone, my earbuds with me, so hopefully you can hear me well. We're going to do our 11.1 notes today. I'm actually going to skip on the vocab to start off with. We can discuss that later, but I want to get right into just the content of this lesson. We're starting our lesson about circles, and first thing is we're going to give you an equation here that says the circumference of a circle is equal to pi, which is an irrational number, times the diameter, and the diameter is from one side of the circle through the center to the other side. Or you can say 2 times pi times the diameter because your radius is half of a diameter. So you could double it times pi. So it just depends on what's given to you. And we'll see examples here shortly. Circle. Then we have the arc length. And the arc length itself is the physical. If I was able to take a bendable tape measure, it would be this distance from point A to B along that curve. And to figure that out, we need to know the angle measure of this arc. So the angle measure that APB makes, that arc angle measure. And we're going to also compare that to the whole circle, which is 360 degrees. And I like this bottom one here. So we're going to take the measure of the arc divided by 360 degrees and multiply it by 2 pi r. And that'll give us the arc length. And we'll see that here soon as well. And then last, we have some formulas here of how to convert degrees to radians and radians to degrees. Now, really quick, if you have a circle is 360 degrees if you go around all the way around this circle. It just so happens that a 360 degrees for a circle in terms of radians is the same thing as 2 pi. So 360 degrees is the same thing as 2 pi in terms of our measurements. That's why we have this lovely little ratio here. 360 degrees is the same thing as 2 pi. And if we look at half of a circle, that would be 180 degrees. 180 degrees is the same thing as just a single pi. So we measure radians in terms of pi and degrees, well, in degrees. So let's actually get to using this stuff. So question number 1 here, diameter of a circle is a circumference of 10 inches. We have to figure out which equation we're using. So we're going to use the circumference formula, and we said the diameter times pi. You can either use the pi button in your calculator, so use that button, or you could use 3.14. So my circumference is 10, my diameter I don't know, and then I have times pi. So to solve this, I'm going to divide both sides by pi, and in my calculator, rounding to 2 decimal places is my diameter equals 3.2, roughly. All right, next, circumference of a circle with a radius of 3 centimeters. Circumference equals 2 times pi times the radius. So circumference, I don't know. I'm going to keep my 2, keep my pi, my radius is 3, put all that in the calculator. I'm going to use 3.14. I'm going to round to 1 decimal place, and I'm going to get, that's roughly 18.8. Again, if we put units in here, the top one we have inches, and this one would be centimeters. Okay, so let's go to number 3. Number 3, we have a radius of a circle with a circumference of 8 feet. So again, I'm going to say circumference equals 2 times pi times the radius. Circumference is the 8, so if I have 8 equals 2 times pi times the radius, divide both sides by 2 pi. Again, you can put 3.14 in the calculator, and I get roughly that the radius is going to equal 1.3 feet. And it's just using these formulas. Number 4, circumference of a circle, and we have diameter, so circumference equals the diameter times pi. So from there, let's fill in what we know. The diameter is 2.4. Keep the pi and keep the c for circumference. And then we're just putting this part in the calculator, the 2.4 times pi. So we get circumference is equal to roughly 7.5 meters. All right, arc length. Let me zoom out. Here we go. Arc length. I'm going to write down the formula here. The formula said that we take, to get the arc length, so arc length of AC is equal to the measure of arc AC divided by 360 times 2 pi r. So let's fill in what we know. Equals. The measure of the arc is that 70 degrees. So I'm going to take that divided by 360. It's like a proportion, right? 70 degrees out of the 360. And I'm going to multiply that proportion times 2 pi r, which just so happens to be the circumference. So I'm going to say 2 times pi times the radius, which is 3. I'll put all that in the calculator, and I'm going to get roughly 3.7 inches. So again, I didn't mention this earlier with the formula previously, but the whole point of this arc length is if 70 degrees is a certain percentage of 360, it's a proportion. So if I know the whole circle was, let's say, 100 inches around, and I know that this arc is supposed to be 25% of the whole circle, then 25% of 100 inches, I mean that arc length is just 25 of those inches. So we're just finding a proportion of the circumference of the circle, and that is the arc length. Then we have our converting. So our converting says to go from degrees to radians. So we start with degrees. We want to have degrees on the bottom. So we're going to take our 60, and we're going to multiply that by, and our conversion factor says we can have the 360 degrees goes with 2 pi, or I like this one, that every 180 degrees is worth 1 pi. So that's my scale factor, my conversion. If I put this in the calculator, next thing you know, 60 over 180 is 1/3, but the pi stays. This is the time we're going to use pi. So my final answer is just going to be pi over 3. So your radians will always have the irrational number pi in its answer. Not a decimal, but actually you'll see the pi written. And then to convert radians to degrees, I'm going to write my initial one. And my conversion factor says if pi is in the numerator, I have to have pi in the denominator. And for every pi, we have 180 degrees. So my pi's cancel. And I'm going to do 5 times 180, then divide that by 6. And my final answer is going to be 150 degrees. All right, there is your 11.1 notes. If you have any questions, reach out to me or your teacher, and we'll see you in the next video or in class. Have a great day.